Dear students, welcome to my classroom. In previous class of mensuration chapter, we have gone through fundamentals of mensuration like surface areas and volumes of cone, cylinder and sphere, etc. And also we solved some problems in exercise 10.1. And in this chapter, we are going to complete the problems in exercise 10.1, as well as we are going to introduce the concept of combination of solids and total surface area of combination of solids. So first of all, take the problem in exercise 10.1. The shape of solid iron rod is a cylindrical. Its height is 11 centimeter and base diameter is 7 centimeters. Then find the total volume of 50 such rods. Students, here it is given that an iron rod is a cylindrical like this, and it is given that its height is 11 centimeters. So here the height of cylindrical rod is h is equal to 11 centimeters, and also it is given that its base diameter is 7 centimeters. So diameter of the rod is d is equal to 7 centimeters. Then the radius of the rod r is equal to half the diameter, that is 7/2 centimeters. Now we have to find the total volume of 50 such rods. So by finding the volume of one cylindrical rod, then we can able to find the volume of total volume of 50 rods. So let us find the volume of one rod, which is in cylindrical shape. So the volume of cylindrical rod is equal to pi r square h. So by substituting the values of h and r in this formula, we get 22/7 into r is 7/2, so that 7/2 into 7/2, and h is 11, so into 11. So by simplification, we get 423.5. So the volume of cylindrical rod is 423.5 centimeter cube. So it is the volume of one cylindrical rod. So the total volume of 50 such rods is 50 into 423.5, so which is equal to 21,175. So the volume of 50 cylindrical rods is 21,175 centimeter cube. Okay, students. So take the next one. A heap of rice is in the form of a cone of diameter 12 meters and height is 8 meters. Find its volume. How much canvas cloth is required to cover the heap? So here the heap of rice is in the form of a cone whose diameter is 12 meters and height is 8 meters. So we have to find its volume as well as area of canvas cloth to cover the heap. Okay. So here we have the shape of cone, and it is given that this height of this cone is 8 meters, and also its diameter d is equal to 12 meters, so that its radius is 12/2. Half of the diameter is equal to 6 meters. Okay, and now this volume of this conical heap is 1/3 pi r square h, because the area volume of cone is 1/3 pi r square h. So that by substituting the values of r and h in this, we get 1 by 3 into pi is 22 by 7 and r square is 6.6 into 6 and h is 8. So by simplifying this one, we get 301.7. So the volume of conical heap is 301.7 meter cube. Okay. So now we have to find the area of canvas cloth required to cover the heap. So to cover the heap, we should cover its curved surface area and need not to cover the area of the base. So that we have to find its curved surface area. So the curved surface area is equal to pi RL. So before finding the curved surface area, we have to find its slant height. So slant height of cone is L equal to under root R square plus H square. Okay. So from this we get under root 6 square plus 8 square, which is equal to 10. So the slant height of the cone L is equal to 10 meters. Now the curved surface area of the conical heap is equal to, that is lateral surface area, is equal to pi into R into L. So by substituting pi is equal to 22 by 7 and R is equal to 6 and L is equal to 10, we get 188.5. So the area of canvas cloth required to cover the heap is 188.5 centimeter square. Okay, students. So, sorry, 188.5 meters square. Now take the next one. The curved surface area of a cone is 4070 centimeters square and its diameter is 70 centimeters. What is its slant height? Okay, very easy to find its slant height. So here we have a cone and its diameter is d is equal to 70 centimeters, which is given in problem. So that its radius is 70 by 2 is equal to 35 centimeters, and it is given that its slant height, we have to find its slant height. So the curved surface area of his pi RL is equal to 4070, isn't it? We have the formula curved surface area is equal to pi RL, and it is given that this curved surface area is equal to 4070 according to the problem. So now substitute the value of R, then we get the value of L. So pi is equal to 22 by 7 and R is equal to 35. So then from this equation we get L is equal to 4070 into 7 by 22 into 35. So by simplifying this one, we get L is equal to 37. So the slant height of the cone is 37 centimeter. Okay. So just we have to equal the pi RL to given surface area, curved surface area. Okay. So this is the end of exercise 10.1, and before going to start exercise 10.2, so we have to introduce about the combination of solids. So total surface area of the combination of solids. This is the new concept that we are going to learn. Students, in our daily life, we see the combination of solids like water tanker and cone of ice cream and spinning top, like, and so many toys are the combination of solids, isn't it? So here I have a cone and an hemisphere. So by joining these two, we get a tie which is in the shape of a spinning top, like this. Now the surface area of this toy. What is the surface area of this toy? That is the question. So which part we able to see in this toy? Can you get it? We able to see only the curved surface area of the cone and curved surface area of hemisphere. So the total surface area of this toy is curved surface area of cone plus curved surface area of hemisphere. Here CSE stands for curved surface area. So the total surface area of this toy is curved surface area of cone plus curved surface area of hemisphere. As well as here I have some more figures, and it is a cone and it is an hemisphere, and one more hemisphere is there. So by joining these three, we get the shape of medicinal capsule like this. So now this is the combination of one cylinder and two hemispheres. Okay, so the total surface area of this shape is surface area of cylinder, lateral surface area of cylinder plus curved surface areas of these two hemispheres. So the total surface area of this new solid formed by cylinder and two hemispheres is equal to curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of hemisphere. That is, we can write it as curved surface area of cylinder plus twice the curved surface area of hemisphere. Okay, so let us start the exercise 10.2 based on these concepts. Okay, exercise 10.2. So the first problem is a toy is in the form of a cone mounted on a hemisphere. The diameter of the base and the height of the cone are 6 centimeters and 4, excuse me. Okay, a toy is in the form of a cone mounted on a hemisphere. The diameter of the base and the height of the cone are 6 centimeter and 4 centimeter respectively. Determine the surface area of the toy. That's the question. So here the toy is the combination of a cone and hemisphere like this. So here the cone is mounted on an hemisphere, and it's given that the diameter of the base and the height of the cone. Here the diameter of the base is the diameter of hemisphere also, and it is given that the diameter of the base is 6 centimeters and height of the cone is 4 centimeters. Now we have to determine the surface area of this toy. Okay, so in this picture we are able to see the curved surface area of cone and the curved surface area of hemisphere. So the surface area of the given toy is equal to sum of the curved surface areas of both cone and hemisphere. Okay, so here we have to find the surface area of cone as well as curved surface area of hemisphere, and by adding them we get the surface area of the given type. Okay, so let's start the problem. Here the diameter of the base of the cone is given that 6 centimeters So that here we are drawing the base as 6 centimeters, and then its radius r is equal to half of the diameter, that is 6 by 2 is equal to 3 centimeters. So the radius of the cone is 6 centimeters, 3 centimeters, and also it is given that height of the cone is 4 centimeters. So now we have to find its slant height, because the curved surface area of cone is equal to pi RL, where L is not given in the problem. So we have to find the slant height. So slant height of the cone is L is equal to, we know that, under root R square plus H square. So by substituting R is equal to 3 and H is equal to 4, we get L is equal to 5. So the slant height of the cone in given tie is 5 centimeters. Now the curved surface area of the cone is pi RL, where pi is equal to 22 by 7 or 3.14, and R is equal to 3 and L is equal to 5. So we get 47.1. So the curved surface area of cone in the toy is 47.1 centimeter square. And after that, we have to find the curved surface area of hemisphere. So here the radius of hemisphere is 3 centimeters, and then its curved surface area is we know that 2 pi r square. So we are writing 2 pi r square. So now pi is equal to 3.14 and r is equal to 3 centimeters, where the radius of the hemisphere. So by finding its value, we get 56.52. So curved surface area of hemisphere is 56.52 centimeters square. Here CSA stands for curved surface area. Now surface area of given toy is equal to curved surface area of cone plus curved surface area of hemisphere. So we got curved surface area of cone as 47.1 and CSA of hemisphere as 56.52. So by adding them, we get 103.62 centimeters square. So the surface area of the toy is 103.62 centimeter square. Okay. So take another problem. A solid is in the form of a right circular cylinder with a hemisphere at one end and a cone at the other end. The radius of the common base is 8 centimeter. Find the heights of the cylindrical and the heights of the cylindrical and conical portions are 10 centimeter and 6 centimeter respectively. Find the total surface area of the solid. So here we have to draw the figure of given solid carefully. So the solid is in the form of a right circular cylinder with a hemisphere at one end and a cone at the other end. So we can draw the picture like this. So in this picture, one end of the cylindrical rod had cone and the other end hemisphere. So now the total surface area of this solid is equal to what should we able to see here? Curved surface area of cone, curved surface area of cylinder, curved surface area of hemisphere. Okay, so the total surface area of the given solid is equal to sum of the curved surface areas of cone, cylinder and hemisphere. So we have to find the curved surface areas of each figure, and by adding them, the total surface area of the solid. So first take the cone. So for the cone, the measurements are given that radius is 8 centimeter, because it is given that the radius of the common base is 8 centimeters. So the radius is 8 centimeters and its height is 6 centimeters. So the curved surface area of cone we have is pi RL, but the value of L, that is slant height, is not given in the problem. So first we have to find the slant height. So the slant height is L is equal to under root R square plus H square. So by substituting R is equal to 8 and H is equal to 6, we get that L is equal to 10. That the slant height of the conical part is 10 centimeters. Now the curved surface area of cone is pi RL. So by substituting R is equal to 8 and L is equal to 10 and pi is equal to 3.14, we get 251.2 centimeters square. So the curved surface area of conical part is 251.2 centimeters square. So the second one is, here we have is cylinder. So take the cylinder, and for the cylindrical portion, the radius is 8 centimeters and its height is 10 centimeters. So now its curved surface area is 2 pi RH. So now substitute pi is equal to 3.14, R is equal to 8 and H is equal to 10. Then we get 502.4. So the curved surface area of cylinder is 502.4 centimeters square. And the remaining one is hemisphere. So take the hemisphere here. So the radius of hemisphere is 8 centimeters, because the radius of both cone, cylinder and hemisphere are 8 centimeter. So its curved surface area is 2 pi R square. So by substituting R is equal to 8 and pi is equal to 3.14, we get 401.92. So the curved surface area of hemisphere is 401.92 centimeters square. So students, now the total surface area of the given solid is curved surface area of cone plus curved surface area of cylinder plus curved surface area of hemisphere. So now substitute the values we got. CSE of cone is 251.2 centimeters square and CSE of cylinder is 502.4 centimeters square and CSE of hemisphere is 401.92 centimeters square. Now the sum of these values is 1155.52 centimeters square. So the total surface area of the given solid is 1155.52 centimeters square. Okay, students, that's all for today. And in next class, we shall solve the remaining problems of this exercise. Until then, see you. Bye.